Welcome to chapter 22, where we'll be looking at object extensions. This is a way of adding methods to classes. Now, we are going to see some further ways to add methods to classes later in a few chapters' time, so you'll only want to use object extensions in specific circumstances. We'll talk about when they should be used. In general, you should use this functionality when you believe the author of a pre-written class, which you cannot change, should have included a method, but they didn't. You need to think carefully before you start extending objects in this way. It would be really bad practice to start adding extra functionality to classes using this feature when there is a better or more sensible way to do it. It really is designed for when there's something critical that's missing and you don't have editing rights to the underlying class. We'll then see how to write the code to extend an object. This is a bit fiddly. It involves creating a specific file structure, but that's not unreasonable, as you will tend to plan creating object extensions. They're not something to do without careful thought. This is a more technical chapter than some of the earlier ones, and if you think you're never going to need this functionality, then it's fine to skip this chapter. I've talked about it because this is the way in which Groovy has added extra functionality to some of the Java classes, and you might have a project that does have a particular use for this. I've included at the end of this chapter a practical exercise for you to have a go at, but if you decide to leave this chapter for now, then this won't stop you carrying on with the rest of the course. So let's make a start. So far in this course, we've seen that Groovy has added methods to some familiar Java objects. For example, in Groovy, the integer object has a method called times. This allows us to create a simple loop. This times method doesn't exist in the Java integer class, and yet we appear to be working with a Java integer. This isn't some new Groovy integer class that's been created. What Groovy does is extend the Java integer. It adds extra methods to it. We saw the same thing in use with the file class in the last chapter. The standard Java file class has extra methods when it's used in Groovy. In Java, if we want to extend a class, then we would create a new class that inherits from the existing one. For example, I could create a class in Java called enhanced file, which inherits from the Java file class. That would work in both Java and Groovy. But I can't do this with every class. Any class that's defined as final can't be inherited from. Again, this is the same as both Java and Groovy. You can't inherit from a final class. And the integer class is a final class, so I can't create an enhanced integer class. Groovy, however, gives us the ability to add methods to existing classes, even if they're final classes. That's how they put the .times method into the integer class, and we can do the same sort of thing. Now, this is a very significant move. In Groovy, we can add our own methods to the base classes. If we think that a class is missing a key method, we can add it ourselves. Let's take the integer class for example. Now, I think the people who wrote Java and Groovy should have introduced a .factorial method. If you're not familiar with the factorial of an integer, then this means multiply together all the integers from 1 to the number we first thought of. So 5 factorial means 1 times 2 times 3 times 4 times 5. If we called 5 factorial, I expect we'd get the number 120 returned. That's the result of this calculation. So how would we go about adding this factorial method to the integer class? Well, Groovy gives us a way of programmatically adding new methods and parameters to existing objects without touching the original object's code. Any changes we make will only apply to the current application. We're not touching the base class and we're not therefore changing it permanently. So let's see how this works. We have our base class. This is a standard Java class like integer or string, or maybe even a class we've created ourselves. It's the class we want to add our methods and parameters to, but we can't edit it directly, or maybe we just don't want to edit it directly. The first thing we'll do is create a helper class. This will contain the extra methods and parameters that we want to add into our base class. Then we'll create a special file called an extension module. Note this isn't a class, it's a file in a specified format in a defined location which Groovy will use to tell the Java virtual machine to use our helper class as an extension to the base class. So for our example, we'll create a new class called integer extensions, which has our factorial method in it, and we'll write an extension module to tell the JVM to load this class as an extension of integer. So let's go and do this. So I'm in the Learning Groovy project here. I've emptied out my main script and I've created already a class called integer extensions. Now this is a standard Groovy class. We just need to provide a method here, but there are a couple of rules we need to be aware of that must be followed. The first thing is that the methods we add must be defined as static methods. So I've just put the word static here in front of the method signature. And the methods must have at least one parameter. The first parameter must be statically typed. We say explicitly what type of parameter it is. And as you can see, I've said this is an integer. It's this type of parameter which defines the base class that we're extending. Because the parameter here is an integer, it will tell the JVM we're going to extend the integer class. If I'd put here a parameter of type string, this method would have been an extension of the string class. I think it's normal to call the parameter here self, but you can use any name you like. The rest of this method is standard Groovy code. There's nothing too complicated here, but as the functionality within the method is not the main point of this chapter, I'm not going to go through it. If you're interested, you can always pause the video and take a moment or two to review what this code does. So at the moment, this is a standard class with a standard method. We can test it by calling it in the same way as we could any other class. In my main script, I can do a print line. Now, because the method was static, I don't need to instantiate integer extensions. I can just call integer extensions.factorial and put in brackets the number. We'll go for 5. So if I run that, I'm hoping I'm going to get 120. And I do. So the helper class is a standard Groovy class, but the methods we create must be static, and the methods must take a parameter which defines the type of object we're going to be inserting these methods into. Now let's have a look at the extension module. This is a file which tells the JVM to use our helper class as the extension class. The file needs to be created in a specific location. We need a folder under our src folder called meta-inf, and then a subfolder under that called services. I haven't got those in my project, so I'll need to create them. Note that the folder names are case sensitive. Once I've created the folders, I can then put a file into that services folder. The file name must be exactly what you can see on screen here, org.codehouse.groovy.runtime.extension module, and that's all in lowercase with the exception of the word extension and module, which have a capital E and a capital M. The content of that file is 3 lines, and I've put the general syntax here. We have a module name, and that can be absolutely anything, a module version, and again, that can be set to anything we like. And then here's the important line, extension classes equals, and then the fully qualified name of our extension helper class. If we put it within a package structure, we'd need to include the package structure there. So let me go and create the extension class now within my project. In my src folder, I first need a subfolder called meta-inf. And that's all in capitals. Under that, I need another folder called services. And then within services, I can create my file. Now note that I'm clicking on a new file here, not a new class. So the file needs to be called org.codehouse.groovy.runtime dot, and then with a capital E extension, capital M module. Okay, and I'll click on finish. So I've got an empty file here. This file needs 3 lines. The first one is module name, and that will equal, well, I can call it anything I like. I'll call this one integer underscore extension underscore module. And we need to give it a version. Again, this can be anything we like, so I guess 1.0 is the standard. And here's the important line, extension classes. Now, I've used the default package here, so I don't need to put the package name in. I can just put in the name of my class, which is integer extensions. So that should do it. If it's worked, what I should be able to do in my main method is print line a number like 5 dot factorial. So let's save and run it and see if that works. Okay, well this has worked, so it means I can now use my factorial method as though it was a part of the standard Java integer class. I've extended the integer class by adding my own method into it. Now it's time for you to have a go at doing this. Let's go back to our hotel manager project. I've opened here the main method, and if I just run this, we'll see that one of the hotel reports prints out today's date, but the format of that date isn't very nice. Similarly, if we look at the letters we're creating, those check-in letters that were defined by the template, we've got the date in here, but it's not in a very nice format. So what I would like us to do is to create a new help class to extend the Joda Times local date object to give us a nice way of printing out the date. Now, I've put on the bottom of the screen here the code that you'll need to create the date in a nice format. This will give us the day, the month in full, and then the year. It's a little bit more readable. So I'd like you to create a method to print a nice format of the local date. I've called the method niceString. So create this in a helper class, then create the object extension file to add this niceString method into the local date object, the Joda Time local date, and then let's amend the template and the run room reports to use this new method. One thing just to be aware of, when you create this niceString method, you will need to import the datetime formatter and the datetime format objects. These are both part of the org.joda.time.format package. So pause the video and give this a go. As usual, you can press resume for a walkthrough or look at the sample code if you get stuck. So I'm going to start by creating a new package to put my extension classes in. I like to do this, but of course you could put it in the models package if you'd prefer. So I'll create my new package, and I'm going to call this one extensions. So within my extensions package, I'll need a new Groovy class, and I'm going to call this one Joda Time extension. Okay, now I gave you on the previous screen the method to put into this class. I'm just going to copy and paste that in here. So it's a method called niceString, which is going to give us the information we need. There's a couple of objects I'll need to import here, so I'll just do that so that this compiles. Okay, I need to import datetime format as well. It looks like Eclipse won't do that for me automatically. Okay, so that's our helper class. Now let's create the object extension file. I've already got the metainf and services folders created here, so I'll just put the file in services. And the file, of course, is called org.codehouse.groovy.runtime.extension module. Okay, and we need 3 lines in here. So we'll have a module name. Well, let's call this one Joda Time extension. The version can be 1.0, and our extension classes, well, I've got it in a package this time, so that needs to be extensions.joda_time_extension. That's the package and my class name. So that should do it. That should add our new method into the Joda Time class. Now what I need to do is change the 2 different places where I want to print out my date. So the first of those is in the template. Here's our template. We're currently printing out the date value. That is a Joda Time local date. So what I want to do is do date.niceString. That's now a method, so I'll need to put that in curly brackets. And the other one was in my hotel reports file. And it's up here. Look, I'm printing out a new local date. So that's now going to be our local date.nice string. Okay, I hope that's going to do it. Let's save it and run it. I'm just going to delete these 3 letters that we've previously produced. Okay, we'll run our code. Fine, so let's have a look at the report first of all. Yes, we've now got a nicer looking date there, 20th of April 2014. And if we look at the templates that have been produced, the letters, I'll just need to refresh my project to bring them in. There we go, check in for 20th of April 2014. That's a nicer looking version. So I hope you got that working. If you did, well done.